personal relationship with our faculty fellow will tell us more than I know about David Cook. So, Pietro Balooski, as many of you know, is one of the most distinguished practitioners that is associated with Oregon, and specifically with the Portland region. He was an immigrant born in Italy in 1899 and studied there and came to the United States in 23, and he had degrees not in architecture but in engineering from Italy and also from Cornell. And he began his practice of architecture as this engineer graduate in the office of Doyle in the city of Portland, and for in about 20 years' time, essentially took over that office, and it became the Balooski office. He produced in his career over 1,000 buildings. And he spent 15 years of that career as the Dean of the School of Architecture at MIT, the oldest school of architecture in the United States. And he is known for being a seminal designer in the sort of modern movement. And the Equitable Building in Portland is the building that is often referenced as being the significant first move in thinking about what a curtain wall is. And is sometimes put in that category of being one of the first. But he did many institutional buildings, many religious buildings, many private houses. And when he died in 1994, he and his wife bequested a portion of his estate to the University of Oregon specifically for this professorship. And it gives us the resources to bring someone special to interact with us every year. And when we invite professors, we try to do it in the spirit of Pietro Balooski's lifelong interests and career. And so I just wanted to express our gratitude to the Balooski family. Marjorie Balooski was very involved in this professorship. She would come to the lectures, and then when she was too ill to travel, she hosted our Balooski professors in her home. She passed away some time ago, and this is no longer possible for us, but she's very much in our hearts, and we appreciate what the family has done for us. And with that, I would like to ask Brooke to tell us a little bit about David Cook.
So I'm going to tell a short tale of sort of a Stuttgart to Eugene connection. But in this room, I would say almost to the day, 20 years ago, Gunter Banish lectured. He was the founding partner of Banish Architects. I was a first-year Option 3 student, and I was very impressed with the work, but I was mesmerized by the way that he described the culture of the office. It sounded exciting and inventive and exploratory and collaborative. And I decided that was a place that I absolutely had to work. So not quite 3 years later, in March of 1993, I showed up on their doorstep and I said, my German is bad, but I would love to work with you. And the secretary at the time said, that's going to be difficult for a number of reasons. And one of them is we hired a gentleman from England a week ago whose German is not great, and we're not running an intensive language program here. They decided to hire me, and David Cook ended up being the person that had been hired the week before, and we struck up a friendship and a long-term communication with one another ever since. David has been with the office for 17 years. He was made a partner in 2006, and he's had an enormous contribution to the office, and I would say to design culture at large. And some of the projects that I could mention that he took a lead on include the Bristol Harborside Center for the Performing Arts, the Danish National Archives in Copenhagen, the Terence Donnelly Center for Cellular and Biomolecular Research at the University of Toronto, the National Cancer Clinic in Heidelberg, which I believe was recently completed, headquarters building in Riyadh, Saudi Arabia, and the kindergarten in Heidelberg. And some of those are either under construction or in planning. I think there's a really natural fit between David's way of thinking about architecture and the culture of the firm. It's a way of thinking about architecture predicated on insight and inventiveness and innovation, but not coming in from outside, but really trying to understand the particularities of the context and the people and the site, and having that be the basis for innovation. And so I think it's a very refreshingly undogmatic approach to architecture. Unabashedly using modern materials, but deploying them humanely and creating localized, wonderful place settings for people. David visited us, directed the Rome program last summer, and he came for a week, and it was obvious to me almost immediately that he'd be a wonderful Balooski visiting professor. Although I would say he's highly capable intellectually and he appreciates strong intellect, his questions of our students had a lot more to do with their gut and their heart, and how their heart related to their architectural intention. So I would say, and this is paraphrasing, how does what you value stir your heart and your imagination, and how might this influence what you are capable of making? So I saw him in a very short time in Rome encouraging a process of self-scrutiny and grounding as the basis of one's creative response. And it's more than self-referential, but it's deeply connected to events and experiences in the world. This idea of creative act as grounding in the world is one of the most valuable ideas we can cultivate as educators. So to me, David is more than a remarkable architect, he's a remarkable teacher as well. David Cook offers a way of considering architecture that resonates with the culture of his firm, and for that matter aligns deeply with the values of his school. Yet he offers an approach that's entirely his own, and I think that's the point. Ladies and gentlemen, may we please introduce and welcome you.
Thank you, Christine, and thank you, Brooke. Yeah, and thank you to the students and colleagues for coming this evening. I spoke last night in Portland, and I would call it a standard lecture in Portland. Yeah, I gave a lecture which really corresponds with our current exhibition. And for those of you who haven't travelled up to Portland in the last couple of weeks, I'd encourage you to do so before the end of the month, because I think the exhibition is really worth seeing. I think it says a lot about not necessarily our architecture, but our way of working, and our way of working together with some very, very able colleagues, engineers, Transolar. Thomas Auer was here a couple of weeks ago, and I think quite a few of you were in attendance and heard how Thomas introduces his work. And some of the slides you'll see tonight are basically the same slides that Thomas showed. And I don't know whether Thomas found these slides or whether we found the slides, but it doesn't really matter. I think what it shows is that actually we work together very, very closely indeed. So I've chosen to call it, or to give the lecture this evening the title, Which Way Forward? And that is not necessarily a title which responds to the way forward for Danish and Transolar, or indeed a way forward for architecture as a whole. It's deliberately ambiguous. Yeah? Brooke, I know, talks quite a bit about the work of our office and his experience in our office some 17 years ago. But I think it's important that for those of you who don't know the office, get a little bit of an introduction, okay? Our office is called Danish Arkitekten, not Danish and Partner. Yeah? Danish and Partner was founded some 50-odd years ago by Professor Gunther Danish. The office is still in Stuttgart, but the architecture's kind of moved on from the Olympics or indeed the Parliament building in Bonn. Yeah? We now have 4 offices, one in Stuttgart, one in Munich, one in Boston, and one in Los Angeles. Okay? I mentioned it last night, but I think it's important for you guys to understand what Stuttgart is about. Yeah? And Stuttgart is a relatively small city, but a very, very wealthy city. The wealth is basically generated by the automobile industry. We have Porsche, we have Mercedes-Benz, we also have Audi just outside the city limits. And then we have all of the supply industries, yeah, who are basically developing high-tech products for these wonderful cars. Yeah? Now, the fact that these people or these industries are on our doorstep also has an impact upon the industries with which we can kind of communicate on a day-to-day basis. Because there's a degree of competitiveness between these kind of the guys out in the Black Forest who are building motor components and then the guys in the Black Forest who are building facade components, yeah? So when I refer to colleagues or indeed luck having these wonderful engineering companies on our doorstep, we also have wonderful, should we say, manufacturers on our doorstep, and that informs our architecture. Our architecture is also informed by the workforce, our staff, yeah? I'm the oldest person in the office at 44. The rest of the guys are probably no older than yourselves, a little bit sometimes, but they're about 26 to 32. Average age at the moment is about 30, yeah? We have about 70 people in Stuttgart, another 12 in Munich, 12 in Los Angeles, and about 15 in Boston, yeah? We work in project groups, yeah? We don't have any real specialists in the office. A project group will see work through from competition through to completion. They will work on computer, they'll work drawings by hand, they'll build models, they'll do renderings sometimes, yeah? They'll do cost calculations, they'll also do at times site supervision, because it's important to point out that at home in Germany, we also fulfill the role of the CM, construction manager. That gives us a great deal of control over the process of architecture. What I'm trying to say is we're not just designers, yeah? The context of the exhibition, yeah? I hope you know who Ben Metcalfe is, yeah, or was. Ben Metcalfe is the founder of Greenpeace, yeah? I think the ecology movement grew up and matured in the Pacific Northwest, and so we're obviously indebted to such people, yeah, for reminding us of our environmental sensibilities. The S word, which I try to avoid using, yeah, although I have to refer to it. I don't know whether I should read some of this stuff or whether you guys should read it for yourselves. I think when it's like that, you can almost read it yourselves. You're probably just as quick as I am, yeah? The second paragraph is the most important, yeah? And that's why I'm reluctant to use the term sustainability. I'm also reluctant to use it because it's very, very complicated, yeah? A definition of sustainability must not just encompass discussion about environmental aspects, but also civic aspects and economical aspects. And as I explained last night, although with the help of really good engineers I can talk about this, and when the projects get bigger I'm charged with trying to talk about this, yeah? There's no way on earth I can talk about that, yeah? And why are we talking about it? Well, some of us talk about it and have been talking about it for many, many years, yeah? But the headlines in the press, well, no one can avoid them. We all are now fully aware of the fact that we live on a planet with a finite kind of amount of resources. So we're encouraged to be good, yeah, in our daily activities. Or you'd like to think we're being encouraged to be good. Yeah? The problem is that we can't really rely upon morals alone, and there should actually be incentives in place which encourage us to be good. Yeah? And what we've been trying to do these last few years is actually work out which incentives are actually out there, because then we can confront our clients with these incentives, and it will make our job a little bit easier in getting certain things through on our projects. There were people who took the lead, or tried to take the lead, many, many years ago. There's Jimmy Carter on the roof of the White House. Yeah? The problem was that within 2 years, Ronald Reagan had taken office, and he stripped these off, believe it or not. Yeah? At the same time, there were these board games, yeah? Making the issues really kind of apparent to the public. Yeah? Not just to the architectural community, but to the public. Please read it, okay? I don't know if you know who this guy is, yeah? He actually worked for the National Coal Board in Britain, believe it or not. but he introduced a new economic model based upon, shall we say, the teachings of Gandhi. Yeah? He was talking about small is beautiful. He was talking about local, yeah, the word local, the word small scale. He was trying to avoid he was pointing out the potential dangers of the multinationals, or a reliance upon the multinationals. Yeah. What I'm getting at with this is it's relatively easy to use the S word. The problem is it's very, very difficult to actually respond to the S word in daily architectural practice. Yeah? And it's even more difficult to convince the public at large of what that actually entails in the process of design and construction. Yeah? Okay, can I move on? Yeah. Talks about complication. Yeah. This is produced by the Centre for Alternative Technologies in Machynlleth. Machynlleth is in mid-Wales, very close to my home. Yeah. So when I go home, I usually go to Machynlleth. And without being derogatory, the reason I go there is because these guys live in a very weird little hippie commune up on the hill. Yeah? The commune is basically self-sustaining. And the people at CAT, the Centre for Alternative Technologies, try to encourage school children to look at the way that they lead their daily lives. Yeah? And they talk about these cycles of which we, as the people, are only a part. Yeah? I said that I'd refer to Balooski today. Yeah? I didn't really know who Balooski was until you asked me to come here, and then I thought I'd better do a little bit of background reading. Yeah? And there's a book on Jenny's desk, actually, yeah, which talks about regionalism in architecture, and Balooski is in this book. Yeah? So I thought it would be appropriate to quote from Balooski. This is 1955. Yeah, he wrote this. Oh, this was a contribution to the architectural record. Yeah. He talks about the complications of modern life. He talks about the dangers of trying to oversimplify. Yeah? We know so much but feel so little. Our emotions are second-hand. They come from book, movies, radio, television, in worldwide uniformity. That was in 55. Yeah? Think of the situation now. Every high street is exactly the same. Doesn't matter which city you go to. We have gotten more and more away from nature and the discipline which nature requires. A rain or snowstorm or strike leaves us feeling stranded or helpless. I think of London, where I studied. A sprinkling of snow, 5 millimeters, half an inch, or less than half an inch, quarter of an inch deep, brings the city to a standstill. Leaves fall on the rail tracks in autumn. There are delays with regards to the train service. You know, you'd have thought with advances in technology would be able to get over such catastrophes. Yeah. We no longer stop to listen or to hear or to see. Our knowing so much and seeing so many unfelt images has drowned our sense of the appropriate. That's a great word. Yeah? Appropriate. I'm going to jump. Information and disinformation. Sue Rofe, I think she came and taught here, or gave a lecture here, yeah? University, or Oxford, what's it called? Oxford Brookes University. So I'm pointing out that she wrote this and I didn't, okay? Because she has a real go at Mr. Bush, yeah? So it's obviously not the current occupants of the White House, but the past occupants of the White House. And I think you should read that, because that I find incredibly scary. Yeah? This is an internal memo circulated between the members of the Republican Party, encouraging them to continue to challenge scientific fact, to mislead the public. Sad, hey? It's no wonder our job gets quite difficult in convincing clients, yeah? Okay? Mr. Gore, in his latest book, Our Choice, published these images. Yeah? These are fabulous, yeah? Council on the Environment, yeah? A group created by the fossil fuel industry, yeah? To mislead the public, to continue to promote the status quo. Great. It's no wonder we have a problem, in deciding which way to go. It's difficult enough if the public were on our side. Yeah? And what will bring about change? Where are these incentives? Yeah? One of the critical causes of the symptoms is the fact that we no longer see the direct repercussions our purchases have on the people, the environment, and the animals they affect. The degrees of separation, this sounds a bit like Balooski, but it's not. Yeah? The degrees of separation between the consumer and the consumed have increased so much that we're completely unaware of the levels of destruction and suffering embodied in the stuff we buy. Yeah? The tool that has enabled this separation is money. This is Herbert Girardet. Yeah? Girardet actually leads the Schumacher Forum right now. Okay? So Girardet is referring back to the teachings of Schumacher, late 60s, early 70s. If we grew our own food, we wouldn't waste a third of it as we do today. If we made our own tables and chairs, we wouldn't throw them out the moment we changed the interior decor. If we had to clean our own drinking water, we probably wouldn't contaminate it in the first place. So what I've been doing the last few months is, and this is basically as a response to my first trip to Powell's, in Portland about a year ago when I came to visit Brooke. I've been trawling through these old books, and this is 1974. I think this is the University of Minnesota, which used to produce some wonderful books, where the drawings are absolutely fabulous, But they use this word, or this term, common sense, and I use the word appropriate. How do we measure that? It's easy to measure that. It's easy to measure that. That's really tricky. Think of the diagram I showed with regards from CAT, But that's But that's what we're really trying to increase, isn't it? Not energy efficiency. We're trying to improve the quality of life, but do it so in an appropriate manner. Now come full circle, and think about what we do together with Transolar. We recognize that any undertaking as substantial as the construction and subsequent operation of buildings naturally consumes considerable natural resources. The questions are, how can we as architects and environmental engineers create buildings which are better integrated into our world, and how we can place less strain on the environment through the process of building? These goals seem contradictory at their very essence. We believe that we are charged with making a balanced, considered response to resolving the respectful tempering of the natural environment based upon local cultural and climatic conditions with the basic necessity of providing shelter. I'm going to show a slide. I wrote that with Thomas Auer, and that was part of the exhibition. That's what we do, or I believe that we do, or we attempt to do. I'm going to show you a slide at the end, which is another quote from Balooski. He says exactly the same. 1955 again. That's the slide that we show our clients at the beginning of each project, because we're trying to get them on board. We're trying to encourage them to think about comfort, to think about the way that they lead their lives, because this has a major impact upon the operation of the building. So we encourage them to dress for the occasion. What I mean by that is, when it's a little cold, don't reach for the thermostat. Reach for a sweater. When it's a little warm, don't reach for the air conditioning unit. Go to work in a pair of shorts and a t-shirt. We have problems with cultural conventions here. But those conventions will change. Individual ecologically sensitive buildings together with environmentally responsible occupiers can place substantially less strain on the available supply of non-renewable resources. In recognizing the cycles of nature as a quality to be emulated, we believe it necessary to question seemingly simple truths. For example, our current definitions of sustenance and comfort. These are obviously not only design and construction issues. We must also reassess preconceptions about our social values, the form of the city, our daily lifestyles, and our own perceptions of the built environment. Yeah? I'm going to go past that one, and I'm going to show, I think this is a Thomas slide. Yep. This is the Flatiron Building in New York in the 1920s. The building's interesting, according to its geometric form, but it's also interesting in the fact that the facades are alive. We have operable windows and we have external sunscreening, yeah? The building literally enlivens not just the city at grade, but also the city when seen from, or this part of the city when seen from afar. With the invention of the air handling unit, some things changed. We as architects got lazy, yeah? And the advances in technology came at a cost to the city, not only in terms of scale and identity. I'm going to go past that one, and I'm going to get to the slide that I showed right at the end last night. Yeah? Because when I talked about the way that we work in the office, I was alluding to the fact that sometimes we as the architects, because we're in charge of costs and ultimately in charge of the construction site, we can literally conduct a relatively large orchestra over a 3, 4, 5-year period. The problem is that as soon as you start taking on issues of, or you have to convince the client of issues relating to, then you have to take on, at times, more and more members to into your orchestra. The problem we're finding, and I think all of our architectural colleagues are finding right now, is that the time we're given by our clients, or sometimes by ourselves, because we're putting the time schedules together, to put the project together, to enter into and maintain a dialogue with the clients or with the local authorities, that time is being cut time and time again. Yeah? So one of the things I say to just about every lecture is when someone asks me, what do you consider the most important aspect in each and every one of your projects? It's that word. Yeah? We have to be given adequate time to thrash out ideas which eventually impact upon sustainable design. Okay. Brookes project. Shown that time and time again. The most beautiful air conditioning unit I know. Yeah? We haven't got them on the roof. We walk around in them in this building. Yeah? They're the gardens. I'm going to try and show you some projects now that you'll have seen and published, and then I'll finish up with 2 or 3 projects that you will have not seen. Yeah? This is a school building. Yeah? Say 50% of our projects are school buildings. Yeah? We work for the public sector. Yeah? It's a single-story building made entirely out of timber with hardly any mechanical systems. Yeah? Our biggest problem is avoiding overheating in the summer. We obviously don't want to work with air conditioning units. So we work with a mixture of internal and external shading and hope to God that the occupiers open the window at the right time or bring down the external shading at the right time. Yeah? These types of buildings demand that the occupiers work with the buildings in an appropriate manner. Buildings made completely out of timber. Yeah? The relationship to the landscape is essential. Yeah? Project I showed last night. I want you guys, because I think 95% of you are students, yeah, to look carefully now, not at the architectural forms, but look carefully at the materials we use on our projects, yeah? And also look carefully at the types of drawings we're doing, yeah? that we are not doing sophisticated renderings for the sake of renderings, yeah? We're trying to avoid renderings wherever possible, yeah? Renderings are produced in my opinion, far too often and far too early in projects, yeah? A rendering, if it can be reduced to the form of a sketch which gives an idea, is great. But a rendering which is developed to such an extent that it closes down all avenues of expression or investigation is dangerous, yeah? Because a project changes, or from during the course, an architecture changes from its inception through to completion. We all know that. There are so many forces and influences which need to be taken into account after the original sketch, yeah? So what we're trying to do is to be realistic with our clients. So in this case, this is the Oceaneum. It's an aquarium. It's a teaching facility, a research facility. It's not just like a fun palace like the thing down in Atlanta. Yeah. This is a model. Yeah. A tiny little model which was made quite carefully, but then photographed even more carefully, and then worked on in Photoshop. It's just as good, if not better, than a rendering. The interior. Look at the materials. Concrete, plasterboard, steel, glass, and a bit of paint. That's about it. Yeah? These buildings are not expensive. They are spatially sophisticated, but in terms of materials, they are very, very robust indeed. Be it a school, a bank building, or indeed a museum. The architectural form is, of course, expressive. Yeah? It's very, very different to the UNESCO World Heritage Site of Stralsund. You might recognize him. He was here last year. We worked actually together. We worked with Will on this project, and we worked with Will and with Norman Foster on this project. This is the Arizona State University Gateway project, which was 3.5 million square feet. And the reason for showing it is because we work at very, very different scales. We work at both home and abroad. And depending upon where we're working, then obviously our working methods have to change. Yeah? We don't try and enforce a standard Danish architectural working method on different cultures. There's no way we can do that. Yeah? The Norddeutsche Landesbank in Hanover, which I think you've probably all seen, you know, it's been widely published. There's a reason why most people don't have pictures of their office at home. Yeah? Because they tend to look like that. And the reason they tend to look like that is because there are different rules and regulations in different parts of the world, which ultimately define the quality of the workspace or the working environment. And back home in Germany, we're lucky that the working unions basically define the maximum floor plan depth. Yeah? You don't have that here, so you end up with deep floor plans. And if you have deep floor plans, then getting natural light into these spaces and cross-ventilation through these spaces is very, very difficult indeed. So what I'm trying to point out here is that the rules and regulations back home make our life really, really easy. So when you guys see this and you go like, how the hell did you do that? It's dead easy. Because the rules and regulations are actually beneficial. Yeah? So what we did in the case of the Gensheim project, we literally pretended we were working in Germany, and we cut a hole out of a standard American 200-foot by 200-foot block and put an atria in the middle. Yeah? So we do work with natural light and natural ventilation in a typical American office block. I should have really shown a slide from Stewart Brand here. And I don't know how many of you know Stewart Brand is, and I'd encourage you to read his new book, which is, I think it's called The Whole Earth Discipline. Yeah. Stewart Brand wrote the whole, should we say, edited the Whole Earth catalogue. Yeah. The kind of hippie yellow pages of the 1960s. Yeah? He then went on. He's a technology freak, believe it or not. And he went on to write a book that I used during all of my studies called The Media Lab, which was talking about what goes on in the MIT Media Lab. Yeah? And he calls out in his book of the 1970s, 80s, How Buildings Learn. He calls out for buildings which are robust, loose fit, and what was the other word that I used last night? Robust, loose fit, and not necessarily efficient, but we'll come back to that in a minute. I'll remember what it is. Okay? Flexible, thank you. Okay. Now, this is the TDCCBR in University of Toronto, which we completed about 6 years ago, working together with a practice called Architects Alliance. Yeah? And we were given a site, if you can call it a site. It was a backwater, a cul-de-sac. This is college, yeah? I don't know how many of you know Toronto. This is college. This is the university complex. This is the big medical services building, massive thing, a big concrete bunker built in the 70s, yeah? And there are a couple of small-scale historic buildings here. And this was our site, yeah? It's only 60 feet wide or something, yeah? It's about 320 feet deep. The interesting thing about the site is the site defined the architectural form, so we didn't really have to talk about deep floor plans here. We got away with that. We just went straight in with our shallow plan building. This is the ground floor, or the modulation of the ground floor. There's a distinct height change between college and the first floor of the medical science building here at the back. And what we decided was that we couldn't just put a building in this relatively narrow site. We had to create a piece of campus infrastructure which actually linked these buildings with these buildings and gave the university a new front stoop, if you like, sitting on college. Yeah? So here's our shallow plan building. Yeah? You can see some of the ideas, or the, should we say, architectural moves, or environmental moves, if you want to call them environmental moves, that we made in the Norddeutsche Landesbank are actually here as well. So we have a double facade on the front. We have sunscreening devices in the interstitial space. We have decentralized mechanical plants here and up on the roof. Yeah. But I think, even now, the building form is relatively unimportant. Yeah? The lab space is shallow plan, natural light flooding in is absolutely no problem. The nicest thing about the project is the relationship between new and existing. Yeah? This is the new box. This is the existing building. Yeah? And this is the space we created. It's literally a found space. Previously, this was used as a parking lot. Yeah? No one paid it any attention. No one went into the medical science building or through the parking lot. Yeah? So we scrubbed up the old building, put a piece of glass over the top, left off the glass here, and created a wonderful communal space. These are the staircases which are actually missing in this building. Yeah? The staircases which promote communication between the respective departments. I find it quite depressing that you actually have to go into the fire stairs here to move between the floors. Yeah? We have fire stairs in here, of course, as well. Yeah? And if you're not careful, you can end up value engineering such things out. Yeah? But they bring a smile to people's faces when they're being used. It's the interstitial space which has been turned into a winter garden. Yeah? A really nice waiting area. Promote extensive use was written at the bottom before. This is the image we came up with. Yeah? This is how we anticipated the labs being used at the outset. Write-up spaces here, traditional lab benches out here, and depending upon the type of research that's being undertaken, then they can, if they want, open the windows and get natural ventilation. Yeah? So you see exposed thermal mass, exposed surfaces, light and airy spaces. That's what we planned. They moved in, and the space didn't look too bad after a few months when we went into photograph. We went back 2 years ago, and the space looks like that. And what I'm trying to get across here is we shouldn't be too precious with our architecture as well. We should promote extensive use. We should let the people almost cannibalize their workspaces, yeah, they feel at home in here. I'm not suggesting that I would feel at home in here. Yeah? Toronto was interesting because it gave us a springboard with regards to lab design for the Harvard project. Yeah? And although it's written current works, that's a little misleading because the project is currently on hold, even though it's currently under construction. Yeah? We built the lower 4 floors. Yeah? Basements is built. Yeah? Biggest basement you've ever seen in your life. Yeah? But because of the economic downturn, Harvard has had problems with its endowments. Yeah? And they chose to stall the project at what is a rather unusual point in time. Yeah. That's Harvard, which you probably all know. Yeah. Harvard Square is back here. Harvard Yard is here. I'm actually standing in the CERT building here, taking the photograph. Yeah. The interesting thing about Harvard is not necessarily the quality of the individual buildings, although there are 1 or 2 very famous buildings on campus. The interesting thing about Harvard is the quality of space between the buildings. Yeah. How you can move and meander. And we were given a brief at competition, because just about all of our work comes through competition in one form or another, to supply Harvard with 1,100,000 square feet of lab. Yeah? On campus, well, not on campus, south of the River Charles, next to the existing athletic facilities. And 1,100,000 is a big number. Yeah? So we originally ran a little scared. Yeah? We said, this is too big. Yeah? If we produce a building that large, then if we're not careful, we're going to, what's the word? It's to do with human scale. What's the word? Forgotten. Alienate the people who are actually working in this building. We said we did not want to produce a lab machine. Yeah? So we decided to split the program into 4 buildings. Yeah? And then we decided to attack the definition of lab in the context of the new university, should we call it research environment. So the dark blue areas are actually the labs. Yeah? Everything else is kind of a write-up space which can basically be accommodated in something which is the antithesis of a lab, and that's like a studio. So in all of the dark, light blue spaces we have natural light, natural ventilation. And in fact, the walls or screens between studio and lab, they're inherently flexible. So depending upon the type of research that's taking place, then we can make these spaces, the light blue areas, much bigger. Yeah? The 4 buildings are fitted out to different levels of mechanical equipment. Yeah? That means that we can, in certain buildings, we can work with 20 air changes an hour. In other areas, we're working with as little as 4 air changes an hour. Yeah? We did not want to over-specify. We did not want to generalize. Yeah? Typical Danish drawing, yeah? Worked out with the help of Transolar, looking at how we can naturally ventilate certain spaces in the building complex. These are the winter gardens which promote communication between the different research disciplines. Research is changing from day to day. We don't necessarily have biology researchers, chemistry researchers, physics researchers. Everyone seems to collaborate on different projects nowadays. So in each building, we have different project groups. And these project groups change in size and intensity literally from week to week. So we're trying to produce an inherently flexible structure. And the structure, within each of the structures, we have kind of an architectural focus, and that's the communication room. Yeah. That's a sketch model. That's a schematic design, yeah? Look at the sizes of the boxes on the roofs. These are the air handling units, which any lab has to have, yeah? And these are the air handling units on labs which have very much reduced mechanical systems, yeah? Imagine how big they would be if we went with a standard approach. This is a sketch, and it's deliberate. The rendering was actually much more sophisticated. It was almost photorealistic. We then decided to pull back. We decided that this was a DD. We decided it would be misleading or potentially misleading to show too much. We said that the decisions and decisions still need to be made, and those decisions could only be made through a continued dialogue with the client. So we were still talking about what this material would actually be, yeah? What the soffit materials would actually be, what the materials used at roof level would actually be. We didn't want to promise too much too early in case we couldn't afford it at the end of the day. These diagrams are interesting because with the help of Transolar, we actually managed to change the preconceptions with regards to comfort. Yeah? We actually looked at the possibility for rather large temperature and humidity swings throughout the building complex. If you can do that, then you can downsize your mechanical equipment dramatically. And yet, the temperatures at certain times can get up to 96 degrees, yeah? That's really hot, yeah? But the reason we allow it to get up to 96 is because no one actually occupies that space. Or if they're getting up to 78, for example, then they might not be occupying that space on a continual basis. Yeah? So we're looking at how people use buildings and then zoning the buildings appropriately. So for example, 35 degrees is what, 90, I think? Directly at the rear of the glazing in the atria space. Why shouldn't it be allowed to get hot there? No one can walk there. The floor slab is back here. Yeah? And if we can promote a certain temperature differential within these spaces, then we can influence the way that air moves through these spaces. Yeah? In this case, moving from the cool areas to the warm areas, heating up at the rear of the facade, chimney effect, heat recovery at high level. And of course, these buildings have different modes of operation. Summer mode, winter mode, and then hopefully in the shoulder seasons, almost in passive mode in, say, 3/4 of the programmed area. And you guys know this stuff. Other universities don't. And we spoke about this last night, that if I talk about an earth channel, I'd say 95% of you know what an earth channel is, yeah? And what the potential advantages of an earth channel are. So this is an earth channel, and the reason we show this is because when I use the word earth channel, a lot of people in our audiences struggle with it. Yeah? In this case, it was integrated, not in the foundation system, but in the parking garage. Yeah? I don't know how many of you know this. This is a Kobeacts system. This is for reducing dead weight in the concrete superstructure. Yeah? And in this case, project leader, Stefan, is showing how the Kobeacts system can be combined with the pipe work which we use to thermally activate the concrete slabs. Yeah? We had to do this for Turner because Turner were reluctant to take this degree of coordination on board. Yeah? So we literally did a mock-up and showed them how to do it. I'm sorry that's in German, but the Harvard project is interesting because through a continual dialogue between ourselves, Transolar, and the client, we managed to come up with a realistic target to reduce the primary energy by up to 66% compared to any other lab on campus. Yeah? And with that, of course, these kind of things got smaller and smaller and smaller. And I believe we're starting to kind of take on a different role, architectural role, in the overall composition. Yeah? They were not necessarily dominating the architectural composition, they became part of the architectural composition. With Transolar, we're getting ever more ambitious, or indeed with Bureau Happold. Yeah? We're looking at comfort not necessarily in the indoor environment, but also in the outdoor environment. This kind of analysis requires rather sophisticated computers. Yeah? And what we're looking at here is wind speed, yeah, in the spaces between buildings. Because there's no point in us talking about putting a cafeteria as a public amenity at grade if that cafeteria or the terrace to the cafeteria cannot be used at certain times of the year due to kind of the influence of wind. So again, talking about best use or appropriate uses of resources. Using this type of modeling, we can anticipate where potential problems may occur. Yeah? And as you see, as we get further on in the project, the renderings become a little bit more sophisticated, a little clearer, but we're still careful. Yeah? So for example, although we're talking about a form of natural stone in the facade, we still haven't decided upon the format of that stone. So we're shying away from showing it. I don't know how many of you know anything about a thing called deep heat mining. Yeah? When you talk about efficiencies of scale, then the Harvard project allowed us to investigate something rather remarkable. And that was not just to look at harnessing the relative coolth or the relative warmth of the ground just some 40 meters or 120 feet below the building and put in a conventional geothermal system, but to look at the possibility of dropping 2 boreholes 1.5 miles into the Earth's crust, and then bringing up water, or passing water down, bringing it up as superheated steam, and running not just the energy plant for our building, but running the energy plant for the entire campus and turning Harvard into a net energy supplier. Yeah? That was an interesting conversation that really was, at first, not necessarily encouraged by the university, but because of the time we had on the project and the contacts we had to various people within the university community, it was possible for us to look at ideas about energy supply far beyond the kind of the confines of our small 1.5 million square feet. Yeah? I don't know how many of you have seen this. Yeah? This is our newest project. This is the Unilever headquarters in Hamburg, which is a big office building. The competition was in 2006. We started planning January 2007. We started construction just 3 months later. And the project was completed less than 3 years, in a period of less than 3 years. A so-called fast-track project. That can be rather daunting because if you're not careful, all the avenues of investigation, depending upon how you go out to tender, need to be closed down before you start construction on site. But in this particular project, because of our role as a CM, we could send certain packages, works packages, out to tender in a stage process. So design and construction were running parallel. On a relatively large project, what's that? 38,000 square feet? That's 400,000 square feet. It's our competition entry. It's deliberately sketchy. This is Herzog Dömeron, just down the road. This is our little building in here. This is a master plan, anticipating a block building, a perimeter block building, and a small tower. So this is our interpretation of the tower and our interpretation of the block building. All of these things are just the master plan. This is our building. These terraces here, the external works, are from Morales. You've probably seen these photographs. They're really quite beautiful. And the original idea was to encourage the public not just to go beyond our building to the River Elbe, but actually to go through our building. This is our tower. This is our competition sketch. Don't ask me what the facade is made of at this stage because we didn't have a clue. All we decided was that we would work with a relatively shallow plan building with a large central atria. And the atria at times would open up towards the Elbe, the river, and Hamburg Harbour, which is probably, I think, the third largest working harbour in the world. This is the work of Morales, and this is the forecourt to our building. Interior perspective. The computer, I don't know if this was, I think this was mostly Photoshop, to tell you the truth, A a SketchUp model and then Photoshop over the top, and then in order to kind of emphasize the ambiguity, sketched again over the top of that. So this is really a collage. And you can see here the physical and visual transparency through to the harbour. That's the site. Yeah, one of the largest construction sites in the world right now. Yeah, very, very large master plan. Herzog de Meuron's El Parmoni, which is under construction. OMA's Donut building, the terminal for the big ferries. This is the Queen Mary, which comes in here, I think, twice a year. Only stays for about 3 days on each time. Yeah. The interesting thing about that, the Queen Mary, is that it has a major impact upon its immediate environment, because this ship doesn't switch off its diesel engines when it's in harbour. These diesel engines work the whole time, polluting the atmosphere. I'm going to jump past those because they're not so important. A typical Danish floor plan. Yeah? The large atria at the centre, terraces opening out to the river. Even the tower, which is in the second row, if you like, has great views through to the river, literally by pulling this building back, sacrificing some of the potential square footage at grade, and then putting up an extra floor which wasn't necessarily anticipated in the master plan. We wanted to make sure that this building also had something of the harbour. The original sketch, to encourage the public into the centre of the Unilever headquarters. The Elbe here, the terraces from Morales here. During the course of sketch design, the rendering got a bit tighter, yeah? We still don't really know what the external facade is at this time, or we didn't. We knew we couldn't afford glass, yeah? We knew that a double facade on a building this size would actually blow the budget. But we really wanted to take advantage of the properties of a double facade, the physical properties of a double facade. Yeah? At the end of the day, we actually got the building to open, not just to open up towards the city, but open up towards the water. And you can actually walk straight through the building. There's a public cafe here, and this is now one of the most cherished spots on the Elbe, that everyone comes here and actually takes an ice cream. The ice cream is what they call magnums. They're produced by Unilever. Yeah? You can see the double facade here. The steps are interesting in that they actually help mask what is a really major problem in the harbour, and that is floodwater. Yeah? This was during construction. Yeah? These are Morales' terraces. Yeah? All of these buildings here literally sit either up on legs, or the ground floor is a disaster. The ground floor is nothing other than an opaque brick wall. So anyone walking along the promenade here, to a certain extent, is faced with a brick wall. Yeah, there is the public realm is far from animated here. So what we tried to do is to bridge that 8.6 meter jump. What's that? 27 feet. Yeah, with a series of terraces or a series of steps. Yeah. Here's our double facade. You see, this is just before completion. Yeah, the double facade is not quite finished here. You all know the advantages of double facades, yeah? They have acoustic advantages, but they also have advantages in terms of protecting the building from wind. And this is a really exposed location in the harbour, yeah? What we wanted to do was to still work with external sunscreening devices. The sunscreening devices occupy the interstitial space, yeah? We couldn't afford glass, so we started working with membranes. Single skin ETFE membranes stretched over a frame and then tensioned via a series of cable stays. Shallow plan, you see it again here. Atria flooding the center of the building with light. Natural ventilation, working with operable windows wherever possible. Of course, during the time that the Queen Mary is in there, then the building operation has to change. If you open the window, then you're not only allowing fumes in, but the noise of these diesel engines just renders the workstations basically unusable. So this is a mixed mode building as well, but a mixed mode not in terms of the season, but in terms of whether or not this thing's in there or not. Yeah. We have an earth channel so that the air is tempered before it goes through the mechanical plant. It's either pre-warmed or pre-cooled. The air is then introduced through a raised floor. We don't have any drop ceilings, because if we had drop ceilings, then there would be a negative effect upon the exposed thermal mass. And of course, we allow the warm air to rise through the atria, and we collect the warm air at high level and through a series of heat exchangers. That's all common sense, yeah? And you guys talk about that, yeah? Go to other universities, you don't hear a word about this stuff, yeah? The rendering gets a little clearer, yeah? Eventually, we cut down on the amount of glass facing south because we wanted to avoid the risk of overheating. So only the big window to the harbour is glazed at the end. The rest of the glazing is north-facing. The building glows at night. Yeah, it's obvious. Day and night. The stretched skin. I think there's a building by Fox and Fowl in Times Square, but it's only done over a relatively small expanse of the building facade. This is the largest single skin membrane in the world, but it gives the building a rather unique appearance. Yeah? It's self-cleaning through the lotus effect. Yeah? Its dead weight is remarkably low because it's so thin. Yeah? It's pretty transparent as well, and it has to be, otherwise we would have complaints from the workforce. Yeah? That's the view through the window, through the double facade towards the water. Seen from an acute angle, then obviously, due to the stretch, it gets a little difficult. Yeah. But here you can see the main reason for doing it. External sunscreening not adversely affected by the wind. Yeah? Highly efficient, remains clean as well. Yeah? So the blades are also reflecting light in onto the concrete soffits. Ground floor, as I said, is open. It's very much like a street in Hamburg. Ground floor is open to the street, and it's animated by public amenities. The building, the Unilever headquarters, really starts at second floor. At ground, we have the Dove Spa, another Unilever product, the supermarket selling all of the Unilever foodstuffs, the cafe up front, and then we have kitchens. Here, these kitchens are actually kitchens where you and I can go in and learn how to cook with master chefs. Yeah. So these are demonstration kitchens. And then there's a restaurant, which actually at the moment is a staff restaurant, but it will eventually be opened up to be used by the public as well. Yeah. So the entire ground floor is basically publicly accessible. Look at the materials, they're dead simple. They're not dissimilar to the other projects I've shown before. Center is flooded with light. LED lighting throughout. We've been experimenting with LED lighting for the best part of 8 years, working together with a manufacturer in Stuttgart, who's actually a friend of the practice. So all workstations and all feature lighting in here is LED. Yeah? I don't think there's a bigger building on the planet with LED throughout. Acoustic qualities also have to be taken on board. Yeah? Therefore, the spandrel panels are acoustically activated. Otherwise, all of this glass would have a negative, and the hard surfaces, the robust hard surfaces would have a negative effect upon the acoustics. It's all common sense. Yeah? It's a city. We all know how cities work. Yeah? This is our building. It works like a city. There are places for exchange of information. Yeah? Some of them are big, some of them are small. Some of them are just a tea kitchen. Others are a tea kitchen plus a copy center, plus what is the most sought after area or sought after meeting room in the whole building. Yeah? And it's not a meeting room which is kind of enclosed. It's something which is very, very open. Yeah? Write-up spaces, yeah, where you can just sit with your laptop and work in a manner which is radically different from the traditional cellular office. I'm trying to show you how we work, the issues which we take into account in the development of our architecture, and how we test these. Yeah? So this is a model not made by an external model maker, not made by an intern, yeah? But made by the team. Yeah? So the project architect, the project leader, is busy on this model, just as the intern is busy on this model. Yeah? And it's not made out of sophisticated materials. It's just made out of cardboard. Yeah? And that's the resulting space. Materials are simple: concrete, plaster, steel, and timber. That's it. I mean, we're not going to talk about that, or that, or that, or that. Exposed concrete soffit, as I said. Typically, that would bring acoustic difficulties. In this case, we worked with an innovative flooring product, so the fresh air is coming through the floor, but the floor is also acoustically activated. They're like carpet tiles fixed onto these micro-perforated concrete panels, if you like. How we work? Developing the tea kitchens, the copy centers, mock-ups, full scale, one-to-one. Not necessarily designing the furniture, but looking at which products are widely available and then tweaking those products, yeah? Combining those products with different other products from different manufacturers. Directly next door to that is the Marco Polo Tower, which when we first did the competition we thought might be an office tower, but actually turned out to be a residential tower. And that's one of the sketches we did during schematic design, where we said we didn't want to consider it a traditional tower. We wanted to consider it as a series of stacked bungalows, yeah, where every unit had its garden, yeah, or gardens, yeah. Where the projecting or the cantilevered building forms actually provide a high degree of solar protection, where we're keeping out the hot summer sun or the effects of the summer sun and allowing for the effects of the winter sun. Yeah? It's approaching completion right now. This is taken about 4 months ago. It's rather complicated, yeah, but most of it's prefabricated. The erection procedures are rather difficult. Because of the cantilevered building form, it's very difficult to hang everything in, yeah. Things literally have to be plugged in from the side. That's rather difficult. Yeah. The lobby area. The materials are a little bit more sophisticated than what we would normally be working with. But this is high end, yeah. These units, because of their location, not necessarily because of anything else, I think purely location, where we have 360-degree views over the entire city of Hamburg. These units are selling for 12,000 euros a square foot, which is what? No, square meter, sorry, square meter. These are New York prices. These are New York prices, though, still, yeah? And right now we're in the process of fitting out all 49 of the units, yeah? And we've actually only ended up getting 3 of them, yeah? Each of the owners has brought in their own architect or interior designer, yeah? We offered our services, but not surprisingly, the, should we say the Kaufvertrag? What's Kaufvertrag? The purchase agreements left it open so that everybody could bring in whoever they wanted to work with, yeah? Another project approaching completion, I need about 10 minutes, okay? It's the National Cancer Clinic in Heidelberg. Now, cancer in Germany is treated rather differently to the way it's treated here in the United States. Traditionally, if you have a problem, you go to see one doctor, then you get sent to see another one, and another one, and another one, and another one, and another one, all in remote locations, yeah? You seem to have a thing called the comprehensive cancer treatment here, yeah? Which means you go to one building, and these doctors or consultants tend to be located in that one building, yeah? Which makes sense, yeah? So what we're doing here for the German Cancer Foundation, Cancer Research Foundation, is to build a pilot project where research in the form of labs, treatment, consultation, and communication between doctors and consultants will all take place in one building. The building is only 110,000 square feet, so it's small. It's over 4 stories, but the project has a very, very complicated program. Yeah, and you're going to see that right now. That's a rendering that we've been using up until the final day. Yeah, we still haven't, even though we're under construction and will be complete in a month, we've never done a photorealistic rendering. Yeah, it's just got a little bit more realistic as we've gone on. Yeah, but we've been very, very careful. It's the ground floor plan. Here's your labs. Yeah, principal researchers, window ventilation, research lab benches. Depending upon the type of research they're doing, they can also have window ventilation. All of the wet areas, intensely serviced areas here in the middle. So the lab is basically an orthogonal form. The clinic, where you go for your infusions, is out at this end. And in between are the consultation rooms. Here's the entrance hall. Okay? Hedges providing a degree of visual protection from the streets or from the paths which surround the site, and give gardens which in the summer months can be used by the patients or indeed the partners of the patients, because people are going in for 2 hours, 3 hours, 4 hours, and often are just literally walking around with something stuck in their arm. Yeah? The building is deliberately anything but a typical university or typical hospital building. Yeah? We're on a very large teaching hospital campus, and the brief called for something which was the antithesis of a typical research establishment or the typical hospital building. Yeah? Therefore, we chose to be rather expressive in the form, and we chose to respond to the different functional groups in a fairly kind of direct manner. Yeah? So you've got your meeting conference facilities up here. These are where the offices for the doctors, where they sit on a daily basis. Yeah? Then they go downstairs for their principal research, or on the same floor sometimes the principal research, and then the labs there. Elevation. Dead simple. Yeah? It's actually based upon a SketchUp model. Yeah? Glazed facades, and this is a rendered facade, yeah? What's a render in German? I mean in American. External, yeah, thank you, stucco. Yeah. So it's just a stucco facade where we've decided to treat the reveals, the window reveals, rather differently. Yeah? These are the roof lights to the central atria, and they're facing north, of course. And because of the geometry of the building, then the elevations start to look ridiculous. Yeah? But of course, we're charged with producing the north, south, east, and west elevation. I think it gets rather interesting, the discussion about those type of drawings when you're working with these kinds of geometries. Again, interior perspective, it's a photo montage, a very, very, very quick SketchUp model, and then worked on over time to kind of convey a mood or an atmosphere. Yeah? Again, we're shying away from being too genau, yeah, or too precise. Yeah? The reason for that is because we're still not sure about the spacing between, what's it called, the posts to the balustrading, or still not sure about what kind of handrail we have. Yeah? So there's no point in putting it in there. Yeah? And actually, subsequent to that, we went back to this kind of stuff, yeah? Which is even more kind of direct. And all we're trying to do here is explain to the client, to the users, where these different materials actually are. Yeah? Where we have timber, where we have glass, where we have natural stone, where we have carpet. Yeah? Where we have the need for signage. Yeah? Where we have a change in materials at a desk. And if I may, this is what I would encourage you guys to do. Yeah? There's no need to render. It doesn't do anything. It just consumes vast amounts of time. Yeah? The palette of materials and colors used throughout the building, deliberately restrained, because otherwise, together with the geometry, it would be just far too much. Physical models, then worked on further in Photoshop. Yeah? Physical models, tiny. Yeah? But you can get the story across. You get the idea across. And encourage the client to participate in a discussion about what type of chairs we should use, what color the wall should actually turn out to be, how heavy the curtain should be. And of course, if you've done one of these things, the renderings you can turn it around into a night shot pretty easy. Yeah? This is the project under construction. Yeah, we should be open, as I say, in about a month. The stucco facade with the deep reveals, the curtain walling with the opaque spandrel panels, also treated in glass. Yeah, different colors of glass, different reflectancies. Yeah, in order to encourage this orthogonal block to change its appearance depending upon lighting conditions, and then inside. Concrete, steel, glass, and timber. Concrete, steel, glass, and timber, and the north lights. Yeah? I think this is the last one. No, there's two more. We'll be finished at 7, okay? This is really nice. This is a project. This is a picture taken in the 50s. This is the German ice speed skating team, yeah, in the Alps, yeah. So you all guys know about ice speed skating, and traditionally it took place in the open air. But one day, the tractor fell through the ice, yeah, and after that they decided it was too dangerous to have athletes skating around on outdoor rinks in the Alps. So they built an outdoor rink here at the foot of the Alps on a concrete plinth. Yeah? And up until a year ago, this was used for the World Championships. Yeah? This is one of the most dramatic sights I've ever seen. Yeah? We are right in the Alps. Yeah? In the summer months, the Dutch ice speed skating team come here to train on rollerblades. Yeah? On this perfect concrete loop, yeah. The rest of it looks rather dilapidated, yeah, and has since been knocked down, yeah. That's what it looks like in a winter season, yeah. It's 220. What's 220 meters? 260 feet? No, more. Sorry, 700 feet. That's 700 feet. That's 90 meters. That's 270 feet. 300 feet, yeah. We were charged with putting a roof over that, yeah, without any columns. And at the same time, we were charged with leaving the concrete circuit in there because of the high degree of servicing which is actually embedded in this concrete. Yeah? And this all has to be done by February of next year, because then there's a run out for the next World Championships. So we decided to put a cloud over the ice rink. And the cloud should obviously let daylight in, yeah? Because there's nothing worse than going into a hall when you've had that for the last 30 years. So we're trying to bring daylight I say daylight and not sunlight because sunlight will impact upon the ice quality. Yeah? And that's another reason why they're moving indoors, because the ice has to be perfect. If it's not perfect, then they can't set world records there. Yeah? And of course, these things traditionally consume vast amounts of energy. And what we're really interested in here is bringing in natural daylight in order to improve the experience, but bringing in natural daylight in order to reduce electrical loads dramatically. Yeah? And at the same time, we want to ensure absolute optimum temperature and humidity conditions in the various parts of the hall. So different temperature and humidity for the audience to that directly above the ice. And if we're not careful here, we end up with problems associated with fog building over the ice. Yeah? If we get fog over the ice, then the cameras can't see the skates going around the corners, yeah? Or around the curves. So we've got in some really, really sophisticated modeling, yeah? And we're looking at low E membranes as well in order to ensure that the structure is not adversely affected. And we want to avoid condensation buildup there because there has been a problem in the last few years with one of these halls actually collapsing. Yeah, okay. Yeah. We wanted to bring light into the hall, so we wanted to introduce some shed roofs, yeah? And we're looking at a rather distinctive geometry with this oval form. And it was getting a rather complicated, yeah, in terms of bringing light in and holding sunlight out. And we started modeling, and we were worried that the cloud may end up turning into a kind of a lemon meringue pie, yeah? And so we got into rhino, and we got into grasshopper, yeah? And we started to look at how we could modulate the roof using remarkably similarly length elements out of timber, yeah, 20 feet long, and creating a series of ripples, yeah, in order that we could bring north light in through here without having too many different pieces of a jigsaw, yeah. And we ended up with a roof that looks like that, yeah. So there's a degree of repetition in there. There's a degree of standardization in there, yeah. These spans are enormous, 270 feet, yeah. The trusses are 8.5 meters high, which means they are nearly 30 feet high, yeah. And the roof is made almost entirely out of timber, yeah. Only the tension elements along the bottom are actually made out of steel, yeah. These are being fabricated right now in a local shop, yeah. That's what the thing will look like. It's absolutely enormous, yeah. These houses are big, yeah. Any of you who've been to the Alps know that the traditional farmer's house is very large indeed because the farmer and his entire family and 3 generations of family live in them, yeah, and the cattle sometimes, yeah. But this is still absolutely enormous, yeah. These are the fans of the Dutch ice speed skating team, yeah. And this is the low E membrane, yeah, which is to a certain extent translucent, so you're going to see the structure through it, and the daylight is going to bounce around in this interstitial space between low E membrane and roof. And importantly, there will be no light spots on the ice. We will have a very, very kind of level lighting. We'll have very, very even lighting levels across the entire hall. And now I want to show you the last project. Yeah, we've got 5 minutes. Yeah. Riyadh is the capital of Saudi Arabia. And we're doing a project. That's our project. It's one of 80 sites. Yeah. We're this little one here. Yeah. We're 80 meters high. Some of them are 330 meters high. Yeah. Foster's doing 5 buildings here. Will Bruder's doing 1 project here. We're doing 1. SOM are doing 3. I mean, there are about 40 different architects, 20 different architects, sorry, doing various numbers of projects at the center of the new financial district in Riyadh. the interesting thing about the project is that we were given a rather peculiar site, yeah? Other people got much easier sites to a certain degree, yeah? Let's go back. We kind of got this relatively shallow site, yeah? Whoops, sorry. Yeah, that's pinched at the middle. We're fronting onto the wadi, yeah? And I think some of you will know what a wadi is. That's basically the area that floods under the impact of torrential rain. For a very short period, it floods in the desert climate. Yeah. So here we have a kind of a zone which will be rocky, which will be certain trees and scrubs. Yeah. And this is something like 20 feet below the main entrance level, which is on the other side of the building. Here's the main entrance level, the financial plaza. This is literally a gorge between this building and this building. So at certain times of the day, there will be absolutely no sunlight in here. The master plan is put together by Henning Lars, and the idea really is to create shadow as much as possible. Yeah? Now, the reason for showing this is because I'm trying to get across to you guys how simple the drawings are. Yeah? How we kind of make our point to the client, how you move through the buildings, how you enter the buildings, where the control points are at the buildings. Yeah. So pedestrian access, truck or car access at a lower level, yeah. First sketch, yeah, or sketch rendering. The idea here is to provide as much shading to the external envelope as possible. So should we say the traditional thermal envelope is 6 feet behind this stuff, and this stuff is nothing other than a series of baseball caps, yeah, angled positioned at different angles in response to orientation. Yeah. We're also anticipating not just orientation, but anticipating the shadowing effect of the neighboring buildings. I'm going to go past that one, go to that one. Taking a rather complicated drawing, yeah, in terms of surface texture, but then really getting the story home to your granny, yeah? How you go through this building, where the main entrance is, yeah, where the control points are, how you get from here to the main lift course, yeah, how you can possibly go through the building and down the stairs to the wadi, yeah, how the drop-off works, yeah, not really leaving anything open, getting the story across as quickly as possible. You know, I don't really need to say much about that. You can dive into that if you want, but once you've got that, everything's literally explained. Then getting rather sophisticated with the external works, the treatment of the landscape, but referring, instead of imposing a new form of landscape onto a desert climate, looking for clues in the existing climate, yeah? Looking at how we can deal with rainwater runoff. When rain comes, it comes torrentially, yeah? And how we can use a small channel as a threshold. So instead of referring to the line of the curb as our threshold, we're saying that this area here belongs to the financial plaza, this area here literally belongs to our building. Yeah? So there's a discussion about private and semi-private here. Because of the desert climate, the building is also connected to its neighbors at third floor. So there are a series of bridges. Yeah? So the outdoor world is not necessarily used to the same extent that the outdoor world is used here in Portland or in Eugene. It's just not possible. Yeah? It's just too bloody hot. So we're now charged with taking other people's geometries on board for these rather difficult bridges. So we have now a public realm within the building. Yeah? And this public realm is then animated by shops, kiosks and restaurants and gardens. Indoor gardens. It's said that we had a very strange site. Yeah? The strange form of the site saved us from doing a deep plan building. Yeah? We'd have probably tried to avoid doing a deep plan building because of the problems associated with natural light. We wanted to get as many of the we obviously want to get as many of the workstations at the facade as possible. But in this particular climate, we have to be careful about putting too many workstations at the facade, because if you're not careful, then the glare is intense. So you see here, on all sides, we have our baseball caps. Yeah? But even workstations, some 12 foot from the facade, have got direct connection, visual connection to the outside world. The interesting thing about the building is that at the moment there isn't a tenant. Yeah? So we kind of invented a narrative for the building. We've said that it can be used in any one of a number of ways. This didn't come from the client, this came from us. The client just wanted a certain amount of square footage. We've said that's not good enough. We need to anticipate how this building can be used. We need to anticipate multiple tenancies. We need to talk about how people could possibly walk through this building. Otherwise, we're just going to end up with a kind of a donut building with just repetitive floor slabs. And we said we're not really interested in that. We have to offer the users different ways of moving through and working with this building. So you see the different colors here represent different combinations of tenancies, be they over single floors or over numerous floors. Yeah? In the north tower or indeed in the south tower, as I refer to them. Yeah? The gardens and atria spaces provide connections between these various tenancies. Yeah? The north tower and the south tower. The connection between the entrance plaza and the wadi is then taken even further, and we're actually trying to forge connections between the wadi and the bridge links to the neighboring buildings. At the set between the two towers, we have kind of our sheltered, to a certain extent, sheltered microclimate, where the towers are casting shadow on a series of terraces. These terraces, I don't know if they're actually going to be used at the end of the day, but they certainly provide a visual filter to actually quite a lot of glass and concrete which is going up in the immediate environment of this building. These are the schematic design models, which are, again, are deliberately simple, trying to get the idea across. It's interesting when you go to Riyadh and you see the works of the other architects, and you see sometimes the other architects have gone much, much further at schematic design and are actually showing glazing bars in their models, yeah, even though the models are tiny. That's what I'm talking about, not closing down too many avenues of investigation too early. Trying to get the client to buy into the idea firstly, before moving on. We're working together not just with we're working with Bureau Happold on this one, not with Transsolar. We're working with Bartenbach in terms of lighting. Yeah? So we're putting models in artificial skies, and we're also doing daylighting analysis. Trying to cut down on glare, trying to get daylight into the floor plans or into the depths as much as we possibly can, reducing the reliance upon artificial lighting, yeah? While maintaining, of course, views out. So we have a fairly mundane facade, if you like, thermal envelope, yeah, unitized system, and then we have these things thrown out front, my baseball caps, yeah, and we have 3 different types of openings depending upon exposure and depending upon relationship to neighboring buildings. It's also important. This is the important view, the view down to the wadi or to the entrance plaza. The view up to the open sky is dangerous, of course, because that would allow sunlight into these spaces, which would then overheat dramatically quickly, and we would then have an increased reliance upon the mechanical systems. So these are the investigations that we're undertaking at present, actually looking at perforating some of these elements in order that we get more even distribution of light. The renderings for this particular client are more sophisticated than we would normally undertake at this stage of a project. But even here, we're still trying to shy away from the photorealistic. Yeah. The easy trick, yeah, the day and the night. And that's where we are right now. We're still designing, yeah? We're in schematic design, and the thing is under construction, yeah? And so are all of these other buildings all the way around, yeah, which is rather scary. Yeah. They're cutting into bare rock for the basements. Yeah? It's quite difficult, I think, to actually talk about or to show that after talking about a project or showing a project in Riyadh. Yeah. Because basically, you ask yourself, why the hell is anyone building in Riyadh? Yeah, and it's such an extreme climate. But even when we do build in Riyadh, then we are still charged with asking or posing those questions. Yeah. Okay. We'll go to. Oh no, go back. Okay. Because this is the kind of stuff that we've been talking about in studio and in seminar. Yeah. That we've been saying that working on a scale of an individual building is not actually that helpful. Yeah. That we should be looking to work at larger scales if we really want to make a difference. Yeah. We can't really start from scratch. There are too many cities around that need, or problems in existing cities that need addressing first. Therefore, we're trying to establish, and also in seminar, we're trying to establish appropriate mechanisms for the adaptation of cities, yeah, to create what could ultimately be a more sustainable city. I'm not saying a sustainable city because I'm not necessarily proposing that exists or can exist. And these are the new messages, yeah? I like this one. Here comes the neighborhood, rather than there goes the neighborhood, yeah? But Jane Jacobs was calling out for this some 40 years ago. So the messages appear to be the same. The question is whether or not these messages are going to get through, not just to us, but to the man on the street. And I like this one, because he uses this term again. And with that, that's my last slide. But please read it, because, again, it's 55 and it's Balooski. The appropriate application of technology, yeah? Not just the application of technology. Thank you for your time, and thanks for staying so long. Okay. Yeah, it's fine if anyone wants to.
So for those of you who want to stay, Dave's going to take some questions.
It's okay, go. No, come on, Andrew. That's a really difficult one, isn't it? Yes, we have. We did some work in India for the Aga Khan. Yeah, we did a hospital master plan for the Aga Khan, looking at how an existing hospital may basically mutate over time or evolve over time into a much better, not just working environment, but also living environment, because of the chowls that they have around the hospital. Yeah. We do sometimes, yeah, but it's a tricky one because we can't run a business on the basis of one pro bono project after the other. Yeah. We do treat certain projects as research projects, yeah, where we're more than prepared to invest time and money, yeah. But you also have to appreciate that all of our work comes through competition. So to a certain extent, that's pro bono as well, yeah? So we have to make our money somewhere, yeah? We looked at what's his name? Cameron Sinclair, yeah. And that kind of stuff. Or indeed Brad Pitt down in New Orleans. But I don't know if it's for us, yeah? Because I don't want to appear arrogant now at all. Most of our work's for the public anyway, yeah? We're not getting paid extortionate fees for museums around the world and then feel a little guilty and then, you know? I'm serious about that. I mean, we are working for standard fees. When we're working for the public, they're all regulated fees. We're not being paid what Gary gets or what Foster gets, yeah? So, when we did the Harvard project, the fee was good, but it wasn't extortionate, yeah? When we did the Norddeutsche Landesbank, perfectly regulated fee, yeah? When we're doing Incel, the roof over the ice stadium, regulated fee, working for a local community, yeah? Not working for the Olympic Committee, yeah? So, I just say we're careful with how we spend our money, yeah? Because we don't have that much, yeah? We pay our staff well, we don't pay them over the top, but we don't expect anyone to work for nothing, yeah? And in that respect, I think that we are socially responsible, yeah? I hope that answers your question, yeah? Yeah?
So, how did you come to choose to do that project in Riyadh? And because it seems like, I don't know that particular master plan.
Yeah.
That seems to be one of those instant city designs.
Yeah.
And he started naming off all these famous architects. So, why choose that project if there are other projects that could use you more?
There aren't that many other projects that could use it more than ours. Unfortunately, the situation is pretty tough, not just here, but also back home. Yeah, when I say back home, I mean the UK and Germany. Yeah, there's been an amazing downturn in the market. We have an office with 70 architects in Stuttgart, and we like to keep them. Yeah, and we're approached all the time for doing projects in China, projects in Abu Dhabi, projects in Dubai, projects in wherever, Romania, or Hungary, or Russia. And we usually turn them down. Yeah, we usually say no, we're not interested. And in this case, or every now and again, we say, come on, let's try it. Let's see what happens. Yeah, because we can't ignore the fact that elsewhere projects are run rather differently to the projects back home. Yeah, and we should also learn from those. Yeah, so we said, let's give it a go. The client was rather persistent. He kept knocking on the door. He came to see us. Yeah, and the client was not in a rush. The client was also recommended to approach us by the master planning architect, by Henning Larsen. I don't know if you know Henning Larsen's work, but it's also really, really good. And we got a call from Henning Larsen, asked us if we'd go after it. Yeah, they wanted to see us involved in the project. So we decided to have a go. Yeah. And I'm not promising that we'll get all of that stuff into the project, but up until now, the stuff that we've been talking about has been very well received. Yeah. And I think if we can make the first moves, then it may make our life easier in years to come if we were ever to go back there and plan. Yeah. And I hope that when we're talking about quality of the working environment, that we can up the ante a little bit. Yeah. For some of our colleagues, or make their life a little easier as well. Yeah. So that's why we're doing it. Yeah, because we thought we'd give it a go. We wanted to see what we could learn from the process. Yeah. That's why we came to the United States. We wanted to see if it was possible, or we wanted to see how a Danish architecture would evolve in respect to a different cultural background. Yeah. Because the buildings we do here are different to the buildings we do back home. They're radically different at times in terms of the build quality. They're radically different. Yeah. So, in terms of the response to climate, they're radically different. Yeah. So, it's an experiment. I'm not suggesting that we're going to set up an office in Riyadh and do one project after the other out there, because that's not our way either. Yeah. Okay. Yeah.
How did you justify that to the client, losing that much square footage in that area?
We didn't lose any space.
You didn't lose square footage by making a...
No, because the client gave us an envelope that we had to work within, 200 feet by 200 feet by 200 feet. He didn't specify the number of floors. Yeah. So basically, the space that we sacrificed in the middle, we got back by putting a couple of extra floors in. Yeah. And we got a couple of extra floors in by actually challenging preconceived ideas with regards to floor-to-floor heights. Floor-to-ceiling height remains exactly the same. Just the amount of space given over to technical installations is radically reduced. Okay?
In your intro, you eloquently talked about 40 and even 60 years ago, people were talking about sensibilities that they're finally remembering maybe now. And this isn't an architecture question more than, are you optimistic that these things that you're doing, these big changes, can be received, especially in light of the political situation where I think some conservative trends coming back. I wonder if what you would say, Mike.
No, I don't want this recorded, okay? Because I'm serious. I'm not sure if I know what I'm talking about, okay? This is a really nice question, because this is the question that I posed to Charlie last week when I was dealing with Charlie. Yeah? And Charlie said, talk to John. So I'm going to talk to John on Tuesday. And I'm going to talk to some people up in Portland about it as well. Because I'm trying to work out for myself what went wrong last time around. And it's an interesting one that we can all talk about, because the messages were pretty loud and clear in 1973. Yeah? And at times they were a little clearer than they are now. Back in Germany, we had car-free Sundays, where the autobahns closed down and people went and walked on the autobahns. So it was pretty bloody clear that there was a problem, and a big one. Yeah? Carter did something, or tried to do something. He entertained Schumacher and started looking at different economic theories. Yeah? Unfortunately, Reagan came in and promoted a free market economy and was supported by Thatcher. And a number of other Western and the large industries, the big industries were hardly likely to turn down that opportunity. And what I'm thinking right now is that this sounds silly, but I think it's true. That at the same time we saw the growth of the advertising agencies worldwide, and advertising agencies were hardly going to get their fees paid, or the same type of fees being paid from the hippie movement. Yeah. So it's not surprising that they jumped into bed with the big businesses. Yeah. And so the power of big business, together with advertising agencies, basically meant that we went through a 20-year, 30-year hiatus. And it's only now, with the growth in information technology, that, through the growth in information technology, that big business realizes that they cannot continue to kind of run roughshod over the general public. That we're all much better informed. Yeah? Mainstream is much better informed than they were 40 years ago. So I'd like to think that the response this time around is going to be different. Yeah? I'd like to think that. Because when you see what the guys from the University of Minnesota did, yeah, some of the books that they produced, they are fantastic. Yeah? Charlie wrote a book that basically talks about some of the same stuff, and he wrote it a long time ago. Yeah? And to a certain extent, that's just been forgotten. There are certain schools where it's not been forgotten. This is one of them. Yeah? But the schools aren't going to help, are they? These kind of ideas have to get to mainstream. Yeah? And they weren't given a chance last time around. Everyone knows what you're wrong. Yeah, the politicians all know it. Big business, they all know it. They've just been delaying the shift as long as they possibly could. And the question is whether or not they can delay it any much longer. That's my take on it anyway. Yeah. I'm kind of optimistic, I suppose.
I appreciate that. It's clear.
But I mean, we talk about energy saving or energy efficient buildings. It's not going to be easy, is it? We can do it with our little buildings around the world. Foster can do it with this, Larson can do it with this, Newell can do it with this. We can all do it, yeah? But think of all those houses that were built in the desert, Phoenix. Think of Main Street. Main Street needs to change, and change fast. Yeah? Because you think about the percentage of buildings that have to go up to designed by architects.